Our next topic is the exterior angle theorem, and I want to approach this two different ways, so bear with me while I talk through this. It's actually quite simple, but it's also deceptively simple, and I want to make sure we're not missing any of the parts of it because we're just glazing over something that seems really easy and obvious and uninteresting, because it's actually very useful in geometry. So any triangle has three exterior angles. I'm going to draw a diagram in just a second, but I just want to say right now, and I want you to grain this in your head, when you're finding exterior angles, make sure you are measuring correctly. You're going to be extending sides of triangles, and the extended sides should never cross each other. They should be spiraling off in the same direction, and I always think of spokes of a car wheel. Okay? Okay, so any exterior angle is equal to the sum of its remote to interior angles. And when I say remote to interior angles, I mean like this. Okay, let me just do this actually. Okay, I mean this. If I have a setup like this, okay, and here's my triangle with angles 1, 2, and 3. I can extend this side, okay, we can even call this A, B, and C. I can extend side AC out farther, and I create a fourth angle right there. And the measure of angle 4 equals the measure of angle 1 plus 2. So notice what this is saying, okay? Angle 1 plus angle 2 equals angle 4. So why is that exactly? Well, if you think about it, it has to do with the linear pair here and the triangle angle sum. And actually, why? I have a short proof. So let's look at this proof. Let's just look at this proof. Okay. Well, here's our triangle. We know that angle 1 plus 2 plus 3 equals 180 because that's the triangle here. And we know angle 3 plus 4 is 180 because it's a linear pair. 3 plus 4 is 180. Then 1 plus 2 plus 3 equals 3 plus 4 by transitive. So I'm just taking this bit and this bit, and I'm saying, okay, since they're both equal to 180, I'm just going to set them equal to each other, okay, by transitive. But then by subtracting angle 3, I have 1 plus 2 equals 4. And so there I am, QED. Okay. Now I want to go back to what I said earlier with any triangle has three exterior angles. I said that, but I didn't explain what it meant. And I mentioned this whole bit about spiraling off in the same direction. Well, this is what this is going to look like. Here is our same scenario that we were looking at just a second ago. Okay, so we have our regular triangle. We have already extended off one side. Okay, so we have this angle now. Here's one of our exterior angles. Okay, there's one of our exterior angles. Now, to find the second and third exterior angles, notice that we've extended this side, so we're not going to be extending this side anymore. You're extending each side of the triangle only once. And so to figure out which way you extend them, let's go to the next side. Let's go to this side. Okay, so we can either extend this going down or going up. Do you agree? And the answer is we have to go down here, because if we were to extend it going up, it's going to look like this. And if you notice, it's going to clash with the direction of this one. So this one's going up this way and this one's going this way, and it's almost like they're closing in on each other. So we don't want to do that. We actually want it to go the other way. And let me explain why. Let me just get rid of this. So we don't actually need that. So we need it to go this way so that when we are extending it, okay, so we're extending that one that way now, And I hope you're starting to see this a little bit. We're extending that one that way, and we're extending this one this way, right? So this is now part of this whole line here. Nope, and I'm smearing my ink a little bit. Sorry about that. So that creates this exterior angle, right? And notice that those are kind of spiraling off in the same direction, and it'll really become clear now. So the last side I need to extend is this one, and I know I have to go this way because it can't touch the other ones. So this side I'm going to extend this way, right? And notice that I've created a third exterior angle right here. So what I'm doing with this, let me just back out so we can see this whole picture situation now. So if you notice, I'm extending this side out this way, and that side out that way, and that side out that way. And I like to think of it like it's the wheels of a car. So if you have the wheel of a car here, the fancy sport wheels, and they're kind of doing this thing, and you have the hubcap in the middle, and this one may be going out that way, and this one may be going out this way. Even though they're curvy and whatever, even though they're looking curvy and whatever, if you think about it, if this one moved this way, it's going to overlap with that one exactly, and if this one moved this way, it's going to overlap with that one exactly. That's what I want this to do. I want these to be able to rotate around, and the little angle measures that I'm doing here, these little red angle measures, none of those are going to clash with each other. So I've got one facing out this way, and I've got this one facing out that way, and now I've got this one facing down that way, and notice none of them are clashing. They're not going in the same direction. If I had gone back here and extended this out this way and done it that way, then those are going to be clashing with each other. See that? They're going to clash, and these two exterior angles are opening up on the same side of the triangle. Does that make sense? So I want to avoid that, and I want to only have one happen for each side. So let's go over some examples of all this. Let's go over some examples of all this. Okay, so find the measure of this angle when you know that 120 equals this exterior angle. So by the exterior angle theorem, we know that 120 equals the 50 plus the question mark, because it's the two remote interior angles as it relates to that one right there, right? So 20 equals 50 plus question mark. By subtracting 50, I have 70 equals question mark. Here, I know that the question mark has to equal 80 plus 25. So 105. Here, I know that the exterior angle has to equal the 80 plus the question mark. So by subtracting 80, I have 30 equals question mark. Let's do some with some expressions. Does it change anything? The exterior angle has to equal the sum of the two remote interior angles. So we have 18x plus 5 equals 46 plus a negative 1 plus 8. So just going through all the motions here, I can actually just reduce this to 45 plus 8x, and that's an 18x plus 5. So if I subtract 5, I have 18x equals 40 plus 8x, and then we're subtracting, let me get all this on the screen here, then I'm subtracting an 8x, and I get 40 equals 10x, and so x equals 4. Let's do one like this. Let's do this one right here, and we're being asked to find a measure of angle S. Angle S is up here. Angle S is represented by 3x plus 4. So I know that the remote two interior angles are going to equal the sum, going to equal the exterior. So 140 equals 3x plus 4 plus 8x plus 4. And so 140, and then we've got 3x plus 8x is 11x, and 4 plus 4 is 8. So we're going to subtract 8 and subtract 8. 132 equals 11x. So we're dividing by 11, and we're getting 12 equals x. And so now I've figured out what that is, what the x is. So if I want angle S here, angle S is 3x plus 4. So that's 36 plus 4, which is 40.